All right. So you guys, so yesterday you guys were working on these 2 pages, and I do want you to keep them for now. So the only thing that I needed to be turned in was your Pogles. If you still haven't finished them, just bring them tomorrow. Not a big deal. Okay? Okay. So please do not use your time today doing them because I need you to pay attention to what we're doing. All right. So what we are going to do, though, is we're going to take a second to review how molecular things are named. Okay? So you guys spent a long time on naming these guys, right? Ionic stuff. Okay, and so we know that for ionic stuff, you're given a what and a what? What was the big thing? A metal and a non-metal. Good. Okay, so we have, like for example, with this barium chloride, we have metal and non-metal. What did the subscripts mean? How many there were, right? And we needed 2 chlorines for this one because we needed to balance out our charges to equal what number? 0, okay? So we've spent a long time on the ionic stuff. So yesterday, you guys should have also been practicing some of your molecular stuff, okay? So when we're naming molecular compounds, okay? And if you need somewhere to write this, you can write it here. You can write it on the back of that flow chart that I gave you today. I don't care. If you want to write it. If you just want to listen, I'm all for it. Okay? All right. Okay, so when you are naming molecular compounds, okay, and molecular is just another word for a covalently bonded thing, okay? This is usually what you call it, though. Molecular compounds. They make molecules. All right, so what were some things from you guys that stood out in the Poggle? First of all, who's it between?
Not 2 nonmetals.
Right, so it's a non-metal, and you guys are going to have to tell me that again later, so if you didn't know that, now you do. All right, so it's a non-metal. Okay, they have prefixes. Good. Okay, they all have prefixes. Okay, so the mono, di, tri, tetra, penta. What comes next?
What would you say?
So I'm at penta. What comes after? Hexa. What comes after that? Hepta. So septa, I know that's what you guys have learned, is not for chemistry. I know that all my AP kids did that. So, all right, so it's hepta, and then what's after that? Octa.
Oh, yeah.
What comes after?
Nona.
It's Nona. Nona is my favorite. If I become a grandma, I want to be called Nona.
Are you Italian?
Huh?
Are you Italian?
Am I Italian? Yes.
Oh, that's cool.
What does that have to
I don't
Oh, okay. All right, and then what's 10? Deca. Good. All right, cool. All right, so what else was important though? Because those prefixes, as much as you could use them on everything, what couldn't you use it on? The first element, if it was only one. Good. All right, so mono, never used on first element. Okay? So when I'm talking about something like carbon dioxide, we don't call it monocarbon dioxide. That's just silly. It's carbon dioxide. Okay? So if there's only one of your first element, you don't use mono. What else? Yes.
If the ending of the prefix ends in O or A and the beginning of the element starts with an O, then the O or A is taking off the prefix.
Good. So drop
The vowels.
just the OA from the prefix.
Oh, no.
So drop the OA from your prefix if element starts with it.
Let's drop the vowel.
Because triiodide is a thing.
Ah.
All right. So this one is more like if I'm talking about decaoxide, you don't say decaoxide, you say decaoxide, okay? Or tetroxide, okay? So it's just with the O's and the A's. Triiodide is a thing, so you write the I twice. It's kind of a weird. Yeah, triiodide isn't good. That sounds like you tried and you died. That's not good. It's triiodide. 2 separate sentences. All right, cool. And then when you guys were writing the formulas, do you guys agree the most important thing is you just got to know your prefixes, right? Because what did those prefixes turn into when you're writing your formulas?
Oh, the Roman script.
They were the subscripts, yeah. Roman numerals are for Ionic stuff, so the transition metals, okay? All right. So that was what you guys should have gotten from that second POGL, okay? Hopefully you guys saw the hint sheet was up here. You might not have. Okay, if you didn't, you can come see it after class, okay? All right. So what we're going to do is I'm going to put your guys' attention on your flow chart. So go ahead and look at your flow chart with me. And like I said, keep those practice sheets. I am so sorry that this unit, I am being all screwy and not giving you a packet. It's because I made packets and I wasn't happy with them, so they're right here. So I'm kind of trying to figure out which ones make it short, sweet, simple, okay? All right. So looking at this flow chart, okay? Flow charts you've used in the past. You always start at the top or the first box, and then you're asking yourself yes and no questions and following your arrows, right? So I'm giving you guys this one to start with, and this one I would put either in your journal or in a reference section in your binder. You want to keep that one because later I'm going to give you one that looks like this, okay? When you guys learn how to do acids and all those things, okay? So it's going to increase. This is a little part of this one, okay? So make sure you're using this until you get super comfortable and you don't need it anymore, okay? So when you're naming compounds, and it's a big mixture of them, right? So let's imagine that page that I gave you, it was all mixed up. You got to first figure out what type you're dealing with, okay? What did I say we're also going to call covalent? What's that one also known as?
Molecular.
Molecular, good. So go ahead and write that on top of covalent, please. Okay, and how am I going to figure out if it is molecular? What am I looking for?
Non-metal.
Good, non-metal with a non-metal. So we're gonna write that off to the side. Okay, how am I gonna recognize that it is an ionic bond?
Metal and non-metal.
Good. Okay, so if we're going to go on this side first, we'll start with this. Okay. So if we have that non-metal, we tell ourselves, oh, it's a molecular compound. That's when we know we're going to be using our prefixes, right? What do these still end in? Ide. So let's go ahead and write that off to the side. Still ends in ide. Okay. The other thing I want you to write below this, and you don't know what it means yet, you'll see what it means at the end of class today, okay? But I want you to write, don't simplify, okay? Like I said, you guys will see what that means later. All right, so that's kind of it for molecular compounds. So now let's go and direct our attention over to the ionic side, right? Okay, I cannot move that little thing out of the picture.
It's just
So
there.
I know it's just there. All right, sorry, it's not even showing up on my screen. Okay, so it's very random. I'm so sorry. Okay, so if we have a metal with a non-metal, okay, we know that we're dealing with ionic, and so how many elements does it contain? You can either have 2, which is what you guys have been studying. When it has 2, that's called a binary compound. Okay, and we're going to use binary again later when we do acids. Okay, so you can either have binary or you can have more than 2, and those guys are called ternary. Okay, Okay, so ternary ones, you guys have not learned yet, so don't worry about that yet. But you guys have a bunch of polyatomics inside of your periodic table. Okay, you have a whole list of them. My people trying to move on to AP chemistry, you're gonna have them all memorized along with their charges. Okay, so if that's you, I would start this year. Okay, makes it easier next year. So these polyatomics, they will not be ending in ides. These guys are gonna end in ites and eights. And if you want to look inside your periodic table, you can see what I mean. Okay? If not, we'll learn it later.
Phosphate or something like that?
Yes, precisely. Okay. All right. Oh, there it is. Oh. Okay, so when it is just binary, what you guys have been working so hard on, okay, you have to ask yourself, does it contain a transition metal? Where are transition metals located? Which block? D. Okay, so you have to see, is it coming from there? Okay. If it is, we've seen that we need to use Roman numerals to indicate that charge. So go ahead and circle the word charge, because that's the biggest thing people forget. That Roman numeral represents charge, not how many there are. Not the subscripts. It's the charge. Okay? And these end with "ide." Okay? Yes?
That's why they put Roman numerals so you don't get mixed up by, the subscript.
Mm-hmm. Well, yeah. Kind of. All right. If it does not have a transition metal, okay, then you only do your names of your elements, but you still end in what? Ide. So go ahead and put that here. And then we are going to add one little thing to this middle part right here. We're going to say simplify. Okay? You simplify ionic compounds, and you'll see what that means here in just a few. Okay?
Is this without having to put the extra, mono, any of that?
No. Okay. What was the ultimate goal of ionic compounds? We needed a net charge of what? 0. Okay? Okay, so what we're going to see is you guys are going to be held accountable for getting those charges on your paper, okay? And I'll show you what I mean when we get there in just a second, okay? So you might add something else to this. But go ahead and look at that other page that you guys picked up at the door. So take a look at this. Okay. I'm going to spend a little bit of time just running you through these couple basics. This is where I'm introducing you to also metallic bonding. Okay, so there's 3 bonding total in this chapter. We got covalent, ionic, and metallic. Sorry. So for metallic, should not be too bad. Okay. Your metallic bonds are formed between a metal and a metal. Okay? Metals are going to hold their electrons very loosely, meaning that their valence electrons, so the ones on the outer shell, are allowed to flow in a sea of electrons. That's what we like to call it. Has anybody heard of that from middle school? No? Okay, maybe I'm. Okay, so real quick, who can tell me why are they held loosely? Because they're what? Furthest away from, not the middle, but from noble gases. Okay, good. Also, what is the argument across, right? Because they're on the whole left-hand side. Those are the metal guys, right? Zeph. Zeph is your argument. Okay, Zeph, meaning they have less protons than the guys all the way to the right. They're the non-metals, okay? Also, as we add layers, you have your shielding effect. So we're just increasing that distance between that nucleus and those electrons, so they're held very loosely. And that's why metals have this whole sea of electrons, okay? The sea of electrons are the explanation for why metals are good conductors. Good.
Not large, but small.
Sorry. Okay, since electricity is just electrons in motion, okay? One special word I want you to put underneath right here, though, is that we don't just call it a sea of electrons, okay? You guys being pre-AP need to also know
Electric flow.
that these guys are delocalized electrons. Okay, what that means is they are not stuck to their little atom. They're held very loosely. They're delocalized. I will give you guys a visual on that tomorrow. I have a little short video clip, but it shows you, and it makes the analogy to ping pong balls, just how easily they bounce around and stuff like that. That's their electrons. Okay, so that's what it is in a piece of metal. All right. We are also going to come back and talk about alloys again. So please put that off to the side. Who can remind us what an alloy is? We learned it back in Unit 3, Solutions.
The A thing, like singular letter, right?
Mix of two metals. Awesome. Good. It's a mix of two metals. So brass is an example, right? So brass instruments, right? So saxophone, trumpet, all that stuff. Okay. So when you look at those, can you see pieces? So it's made up of zinc and copper. Can you see pieces of zinc and copper? So is this a homogeneous mixture or a heterogeneous? Homogeneous. Good. All right. Nice work. Way to remember that, you guys. Good job. All right. Let's move on to ionic compounds. So this one you guys should be able to shout out your answers. So an ionic compound or an ionic bond forms between a what and a what?
Metal, non-metal.
Metal, non-metal. Okay? Or and so this is talking about what is the names for their ions. Cation is one, and an anion. And I just kind of scribbled out that ion word. Okay. Okay? All right. In an ionic bond, electrons are... So I want you to think about what a cation is. Cation, you guys have told me, has a what charge? Positive or negative? Positive. Okay, so that means did it give away an electron? Did it take an electron? Does it still just have its electrons? It gave away an electron. Anions become negative because they gain an electron. So what's happening there is electrons are transferred. Okay? From the... Where are they transferred from?
Cation to the anion.
Okay? That's what you guys just told me, right? The cation loses his, becomes positive. The anion gains it. He becomes negative. So it's going from metal to non-metal. Cation to anion. Okay? So your metals are your cation or anion? Metals. The stuff on this side. Cations. Good. So label those guys. Your non-metals are your anions. Okay. Okay, this group can't answer. Well, you can. You can learn. Okay. Everyone else, ready? Metals lose or gain electrons? Lose. Good. To form positive or negative ions? Positive. Can you see I'm like drilling this into your heads? Make sure you don't forget this stuff. Okay. Non-metals, lose or gain?
Gain.
Become? Good. All right, so a positive ion and a negative ion will attract or repel? You're not allowed to answer. Yes, good. It's attract. Okay. This can get erased, just so you know. Don't worry about this crap right here. Okay. So what I want you to write, though, is tell me what law was that? What thing told me positive and negative things attract each other? You guys had a whole homework assignment on it. Sorry, with a C.
Covalent.
Nope. Yes, Coulomb's law. Good.
What did we take home with
Okay, so this homework assignment was the one that looked like as you increase distance, what happens to the force? As you add protons, what happened to the force? Okay, so you guys had to do it, and you got a stamp. Most of you didn't get a stamp, and we went over all the answers. Remember that? Yeah, okay. She's nodding. All right. All right. Number 3, an ionic compound can also be called I'm going to tell you this one, salt or an electrolyte. Okay? A salt or an electrolyte. So when I say salt, what is the first thing you think of? Sodium chloride. Sodium chloride. You're not allowed to say sodium anymore. Sodium and chlorine. You can't say NaCl. You can't say table salt anymore. You guys learned how to name. Use the names that you just learned. Okay? So sodium chloride, right? But technically, I could look at my periodic table and I can make a whole bunch of salts. I could say potassium chloride, rubidium fluoride, all that good stuff. All right? So metal and nonmetal, they create these salt-like things. Okay? All the ones that you guys dipped into the flames, those were called salts. Okay, so just so you're aware of that, where have we heard the word electrolyte?
Gatorade.
Gatorade, all right. And the reason we drink is to replace the salt that we lost, that we sweat out. Okay, so all right, so this line is really, really small. So I'm going to write it down here. When you dissolve an ionic compound in water, it can conduct electricity because the ions separate and are free to move around. So once again, you're kind of creating that sea of electrons. You have this imbalance of charges, which passes electrons along, okay? So question, if I were to fill up something with DI water, which is deionized water or distilled water, will that conduct any electricity? No, it's the ions in our tap water that make it dangerous to bring any electronic devices in your bathtub. That's your public service announcement.
If I put it in a plastic bag? Will it still not be?
Technically, no, but I don't recommend you trying it. Okay? All right. Did you guys have a question over there? Or we're all good? Okay. So down here at the bottom, okay? This one, I'm not a huge fan of it, but technically, you guys already know it. And when you see it, this is just making a visual representation of what you guys have been working really hard on, okay? Now, I will tell you, on the test, I am asking you to draw this, so you need to take the notes. You do need to know how to do it, okay? I'm not a fan of it because I think it takes forever, but we're going to go with it. So this is going to be a model of how an ionic compound is forming and all that stuff, okay? So the first thing that you have to start with is you have to start with your Lewis dot diagrams. This is your electron dot notation. How did we used to do that?
Well, you put the element right, or the symbol, and then you put like dots around it.
Good. So something like, let's do carbon. So carbon, how many dots did carbon have?
6.
No,
Wait, 4.
it had 4. All right. So this tells me we all have to look at our periodic tables for a minute. Okay.
That's the main is right.
Okay, so looking at your periodic table, okay, how did we used to decide how to find those valence electrons? How did we, what did I tell you to look at? There were like numbers. So it was kind of like your group numbers, but specifically it was the ones that had the what next to them? The A, right? Or if you want to just start learning it on the normal numbers, you take off any kind of ones. Right? So group 13 has 3, group 14 has 4, group 15 has 5, and so on and so forth, okay? So question, if it goes 1 through 8, what's the halfway point? 4, good. So this whole section right here is our halfway point. So what we're going to see is this guy is going to be plus minus 4 when we're talking in terms of charges, okay? And I want to show you guys this so that we know how to do this, okay? All right, nitrogen. How many valence electrons does nitrogen have? 5. So it would be 1, 2, 3, 4, 5. So is it easier for them to give away 5 or to take 3 on? Okay. Why? By the way, why is he taking 3 on?
To become a noble.
So it can be like a noble gas, okay? Don't forget. So valence electrons, their goal is to become 8, right? Charge, what's the goal? To become 0. Okay, that's stability. All right, good. So since he needs 3 more, that's where we write a -3. Okay? Oxygen needs how many more? 2. So we write a -2. Fluorine needs how many? 1. So he gets a -1.
What about 18?
Okay? 0. Okay, so just so you know, that's where those, on that Pogel, this is where those charges were coming from. Just this, okay? It's how far away are they from your noble gas. So looking over here, let's look at boron. How many valence electrons does boron have? 3. Is it easier for him to give away his 3 or take on 5? Give away. So he has 3 extras. So we call him a +3 charge. And everybody below him is a +3 charge, right? Okay, group 2 is a +2. I got 2 extra electrons. And then +1. Okay? So from here on out, I'm not giving you those charges for these main group elements. You have to be able to look at the valence electrons. Don't forget your midway point is at 4, and then figure out how far away they are from noble gases. Okay, so it just goes, if you look, +1, +2, +3, -3, -2, -1. It's kind of like a little hill, okay? So, so kind of make yourself familiar with those. But what we're about to use is those, okay? So we all good on that now? We remember how to do them? 4 is a +- because technically he could give 4, he could take 4. Carbons are very bondable. So that's why they're in a lot of your organic compounds and things. It just depends. You guys will not be dealing with that one too much. For our purposes, yeah, no, you just don't. Because they're usually gonna be in covalent things, so you don't even need charges, if that makes sense. Okay.
What about the metals?
These guys.
Yeah.
Most of these guys are multivalent, so those ones are ones that you're going to have to figure out. Okay? So you either memorize all of them, or I will show you the way to figure it out, given your anion. Okay? If you notice, anions, do we have to guess on any of their charges? No. So they're your key, they play a key role here in figuring out which cation you're dealing with. Okay? Okay. All right, but that's a little 5 steps ahead. So let's come back to this, okay? We're going to draw our Lewis dot diagram. So we're going to start with sodium. What group is sodium in? Group 1? Okay, so how many dots? 1. All right, so you're going to draw sodium. He's going to get his dot. Okay? And then you're going to put him in brackets. All right, then we're going to draw chlorine. Chlorine's in group 17. How many does he get? 7. So 1, 2, 3, 4, 5, 6, 7. And put him in brackets. Okay? Okay, your first step is you show the transfer. So you're going to take this little electron, go boop, like that. So when I ask you on the test to show me the transfer, this is what I mean. This is the transfer step. Transfer. That's awkward. All right, there you go. Okay. Then you're going to actually draw the model. Okay? So sodium gave away its electron. So it doesn't have any more valence electrons. What charge does it now have? Because it gave away something negative, it became positive. There we go. So we have a +1 right here. Chlorine took on that extra one, so now he has 8 electrons all around him. I am drawing dots. I don't know if you guys can see them. Okay, yeah. So you have 8 dots around him. Close those brackets. He took on an extra electron. So what charge does he now have? A -1. Okay? Okay, so looking at this, your formula is going to be 1 sodium, 1 chlorine. So do you see how you guys have already been doing this? You just did it without pictures. Okay? So you guys have half the battle. Because overall, what is the goal of our charges? They need to become what number? 0. And this part checks out. You see that? So it's all still what you've been doing. This is just how you visually represent it. All right. Let's go down to, well, actually, no, let's do magnesium sulfur real quick. All right. So magnesium. Group 2. How many dots? 2. Good. So I'm going to draw 2 dots on him. Okay. All right. Sulfur. Sulfur is from 16. How many does he have?
6.
6. 2, 3, 4, 5. Sorry. I went dot happy. My bad. Okay, there you go. All right, so he has 6 right now. So we're going to show, that first step is show the transfer. That's your transfer step. All right, now we're going to draw what does it look like after. So we now have magnesium with no valence electrons. What charge did he accumulate? A positive 2. Good. And then sulfur took on those extra ones. So now he has a full 8 or an octet. So his charge is now a -2. Okay? Once again, we have 1 magnesium, 1 sulfur. So it's just MgS. And my charges equal 0. Okay? So the next one, calcium and chlorine. Okay? So calcium. Hold on, let me get a different color. There we go. All right, so calcium has how many? He's in group 2. 2. So we're going to draw 2. Put him in his brackets. All right. Chlorine. Chlorine has 7. There you go. Okay, cool. So we would show our transfer. But we notice what?
It has 1 more.
Right, so chlorine is full. Chlorine's happy, but calcium's like, you can't have my electron unless you bring a buddy. Because calcium is going to either give all of them away or give none of them away. All right? So you guys already, and you guys have seen this before, okay? So we got to have another chlorine. Right? That's the math that you guys were already doing in your head. You saw that this one had a -1, this one had a +2. You got to add another -1, right? So this is just showing it again, okay? Okay, and now we show that transfer. So you have to draw 2 chlorines. This is why Miss Vogel doesn't like this, because I don't like drawing this much. All right, now you're going to show what do they look like after. So I have calcium, who now has a charge of +2, good. And chlorine 1 now has a charge of -1. And then the other chlorine has a charge of -1 as well.
CaCl2.
Exactly. CaCl2. And you are still checking your charges. We have a +2, -1, -1. That equals 0. You're good. Okay? So do we see this isn't? It's not much different from what you guys were doing. Okay? Okay, I'm going to have you guys turn your page over. I'm going to show you the shortcut. Yay! You guys have worked so hard. You're doing a great job. So now you guys get to do the shortcut. All right, so shortcut. Crisscross method. Yay, exactly. Good. That's the attitude. All right. So crisscross method. So crisscross method is going to involve you looking for those charges. So group 1, 2, 3, 4, 5, 6. Okay, all of those things, you got to look for their charges first. Okay? Then you're going to obviously always put your positive one first. Whoa. Positive ion comes first, and then negative ion comes second. You guys already know that. Then you crisscross to find your subscripts. All right? So let's look at this. Sodium. Sodium has a what charge? Okay, look at your periodic table with me. Sodium is in group 1. So he has an extra electron, +1.
If there's an extra electron, would it be negative?
An extra electron is in he can give it away. He has one little electron floating in this outside shell, and he's like, screw this, you need to go away. All right? So, you got it? We understand? That's what I meant. Okay. Sulfur. Sulfur is in group 16. He has 6 valence electrons, so how far away is he from 8? 2, so he's a -2. Okay? Once you have these, you crisscross your charges, and we now write Na2S, and you're done. So So do you see that this just took out all that thinking work for you?
I did that before.
Good.
because I never-
Good. Good.
It's
And some
automatic.
people started making that connection with, well, if this one's 2 and this one's 1, especially with the 2s and 1s, you start making that already. But
So much easier.
yes. However, so yes, this is easier. Yes, I encourage you to use it. There's a catch to it. You got to always check your answers, and we're going to see why in just a second. Okay. So I still need you guys to know why. Okay, so please do not forget everything that you've worked really, really hard to understand. Please do not forget any of that. What is the goal here? The net charge needs to be 0. Awesome. Okay, let's finish these up so I can show you the exceptions. Okay, or not the exceptions, but the catch. So aluminum is from group 13, plus 3. Bromine is group 17, minus 1. Good job. Nice work. Crisscross those guys. We get AL. We don't write 1s. BR3. Done.
C is automatically gonna equal
See how
itself.
I figured out what it was?
Okay.
3 and 4.
So, for calcium and oxygen, calcium is in group 2. What is that?
+2.
+2. Oxygen is in group 16, so -2. All right, so crisscross these guys. You get Ca2O2. But you guys have worked really, really hard. Is that a true statement? Do you need 2 calciums and 2 oxygens?
No.
No, you just need 1 and 1, right? So this is where, I don't know if that's what you were trying to say, but this is where you're simplifying things. That's that simplify thing. So we actually have to simplify this to make it CaO. If it can be simplified, you have to. Okay?
It's only for ionic, right?
Only for ionic, true. For covalent, do not do that. All right. This over here, by the way, is Cr with a 4+. We got to do this example. All right. So if this is Cr with a 4+, and this is oxygen with a what? By the way, real quick, before we even move on, chromium. Chromium, is he a transition metal or a main group?
Transition.
He's a transition, so that's one of those multivalent. So I'm giving you his charge, okay? All right. Oxygen has a what charge? He's in group 16. -2. Okay, if we crisscross these guys, we get Cr2O4. Is that okay?
The CrO2. The CrO2.
Good. We have to simplify it. Do you guys see that?
Yes.
Got even numbers there.
Oh, yeah.
Simplify them, okay? If you have a 3-6, simplify it. If you have a 6-9, you have to simplify it, okay? So just kind of think ahead to those. All right. So CrO2.
Yeah, I've already.
Now, here's the other catch. Ready? Okay, how would you name the first guy? This first one right here. What is its name?
Sodium sulfide.
No.
Yes. Sodium sulfide. Okay, you can't answer again. First, just a second. All right, this next one.
Aluminum bromide.
Good. You can't either. Somebody from the back. What's the next one? Good. Calcium oxide. How about this last one? Right, so the first thing you say, chromium oxide, but it's a transition metal, so we need Roman numerals. So without looking at this thing here, would you be able to tell me that this is chromium 4 oxide? Okay, so that's the other catch to this, okay? I'm going to show you that tomorrow, how you can figure that out really, really easily though, okay? But this is chromium 4 oxide, okay? But that's the other catch, is that with your transition metals, with your multivalent cations, you got to kind of do a little bit of math, but it all comes down to the overall charge needs to be what? That was supposed to be like really loud. The overall charge needs to be what?
0.
There we go. Good. All right. So for the remainder of class, I recommend you do 1 through 8. I have the key and I'll post it up on the overhead right now. Okay?